Okay, so we are on the back page, just starting the video over again here, and I've just gotten the kids looking at question 18. So we made a problem called 18b that I can totally talk about and explain because I want to leave number 18 alone for them to practice. And the first thing we talked about is how that is called the multiplicity. And then I asked what the degree was, and I knew some kids would think it was 2. But now I think you know it's not 2. So Jose, what do you say it is? What degree is it? 4 is correct because there's a power of 1 here and a power of 1 here, also known as the multiplicities are 1. And it's degree 4. Because if you multiply this whole thing out, the lead term, everybody write that down. What's the lead term of this? Y equals what? Don't say it, write it. You had to do that for every problem. You had to write down, oh, what's the lead term? Because you know that negative in the front? That does something. All right, were you aware that this x squared and this x to the first and this also an x to the first, but it's a negative, all get multiplied together and you get negative x to the 4th. Raise your hand if you had that right. Cool. That means it's degree 4 and it's negative. The negative tells you that it's down on the right. Do you remember that deal? There's a negative in the front, it's down on the right. This 4 here does not tell you directly what the left side is. But that tells you that since it's an even number, it's the same as the other side. Well, what was the right end? Up or down? Okay, I don't feel like I've got your participation here when one person mumbles an answer. I'm going to ask that again. The right end. What is the right end doing? Down. And so this is going to be the same on the other end because it's even. All right, what's the degree of this one? It is not degree 1. Try again. It's degree 4. Degree 4 because we put this 2 and this 1 and this 1 together and we got degree 4. Okay. What else can we learn from these? Well, this is a root. No, that's a factor. What's the root? X equals what is the root? 4. What's the root for this one? X equals negative 3. And what's the root for that one? 0. Those are called the roots. There's 4 names for them. Roots is one of them. Roots and zeros and x-intercepts and solutions. I heard that at the same time. Roots, zeros, x-intercept, solutions. If they ask you any of those things, they're referring to these. Are they the same as factors? No, but you get them from the factors. So if I said that the solutions were x equals 5, then x equals 2, then what were the factors? X minus 5 and x minus 2. Do you get how this is called 4 things? Roots, zeros, x-intercept, solutions. These are called factors. Okay. So there's a reminder of almost everything that you need to know, but let's actually sketch this one. So I know it goes through those 4 spots. So I'm going to make an x and a y axis, and I'm going to go through 0 and 4 and negative 3. There, I went through all those spots, and I have to be going down on the right, and then do you see that it bounces somewhere? Remember how this one is a bounce? If you aren't taking notes on this, you're really missing a chance to have an awesome review page to look at right before you take the final. No, you can't have notes during the final, but you could have looked at them right before, as in, you guys take your final, let me think, are you guys third out right now? Okay, so you guys take it tomorrow. No, next day, sorry, next day. You take it the first day of finals, but that isn't tomorrow, it's the next day. Okay.
It bounces on every even multiplicity, right? Not just 2.
Correct. 2 or 4 or 6 or 8 would all be bounces. And the other alternative, if they have powers of 1 or 3 or 5 or 7, they always pass through at that. Yes.
What they stick?
That's if you have a power of 3, and it's just a special kind of passing through. So don't worry about that. Just remember that they either bounce if they're even, or pass through if they're odd. All right, so let's actually do that then. So it's got to bounce at the 4, remember, because of this squared here. So it's bouncing, boing, and then it passes through it, and it passes through it, and it was down on the right. That's what I expected. Since it was even, it was supposed to be the same on the left, and it was. It bounced here because of this multiplicity of 2 right there, and it just passed through the other ones. Yes?
So I know that x-intercept on this one is 0, but on one where like it goes to 0, do we have to like draw it correctly or go through the x-intercept or y-intercept?
The y-intercept is usually a big deal. In this case, it's 0, 0, so it's, yeah. But imagine for a moment, like look at number 18 on your packet. Everybody look at that and tell me, how are you going to find the x-intercept? It makes what? The x-intercept makes what? Okay, you need to repeat after me. The x-intercept makes y equals 0. The x-intercept makes what? Okay, and the y-intercept makes what? Good. So when I say I want the x-intercept, you just make y equal to 0. So you put a 0 over there, and then you're like, oh, I guess whatever makes the equation equals 0. Okay, and if I ask for the y-intercept, you make x equal to 0, and you stick in a 0 wherever the x is. Okay, so does that answer your question about how to find the x-intercept and y-intercept?
A big number though, like how do you draw that all the graph?
If it was so big that you couldn't graph it, then you wouldn't be able to graph it. Would you agree that in this case, you just put in x equals 0 and that won't be that big of a number? So then it'll be fine. Yes?
I remember we did this unit, we would solve for like the last number in the equation, like not the middle step, the last number. What does that mean?
Okay, so if you took mine and put in x equals 0, you tell me, what am I finding when I put in x equals 0? The what? Y-intercept. So that's the number that's at the end. But in this case, it's 0. Why? Because this 0 times all of these other things is just going to make it equal to 0. So that means that it doesn't really have a y. Oh, wait, no, it has a y-intercept at 0. Okay, so let's look at just one more. Imagine for a moment you had this really simple one. What's the y-intercept? Should take you half a second. What's the y-intercept? 3 times 2 is 6. Seriously, nobody could do that? Okay, the y-intercept is where x is 0, so you go y equals 3 times 2 is 6. Does that make sense? How about the x-intercept? That's where y is 0, so what makes y 0? -3 and? Good. Okay, I feel like you've learned a lot about things like number 18. Now, what if you just had to graph it? I mean, it says graph it. Couldn't you just find a whole bunch of points on an XY chart for graphing? I call it your best friend in graphing, because anytime they want you to graph, you can just find a whole bunch of dots and then play connect the dots. I don't think it's the easiest way to graph, but it's a way that will always work. Just make a bunch of points. Okay, look at number 19, everybody. On the yellow packet, number 19. It wants you to do long division of polynomials. Yes, this is something we expect you to know how to do. It is a state standard, like the state of Minnesota says anybody in high school in Minnesota should learn this. It's also on the ACTs, and it's also one of the hardest things. So let's review it. Everybody off to the side, in a blank notability doc, write this. We'll just do a baby one. Yes, how do you start these things? Yes, sir.
You try to multiply, find something to multiply.
Yep. What do I say it always start with? X. Now, will it always be x? No, but it'll always be x or x squared or like x to the third, or maybe it's 2x to the third. Okay, so how do you know whether you've got the right thing? Well, try it. This times this should make x squared, and look, it matches up perfectly with the other one. So it was x. If I had needed it to be bigger, I would have called it x squared, or maybe 2x, if I needed it to have a number in front. All right, then I got to do the other one, this times this, plus 1x. And then I draw a line. And then I go through and make it opposite, opposite. Did you remember that? That's probably the most forgotten step, is you got to make them both the opposite of what they were. And some people simplistically think, oh, you got to subtract, that's all. No, because they can have negative numbers in there, and you got to go change them to positives, and then you're actually going to be adding. So the point is you always make it the opposite of whatever it was. Okay? All right, so now I can actually put these together, and I get nothing, so that's gone, which is good. That was the point. And -3 and the -1 makes -4x. Raise your hand if you had that one right. Good. Now do you know what to do next? Joe Mac, what's next?
Times by.
Wait, got to bring something down first.
Oh, you bring down -4 and then you times by -4.
Yeah, so now you're going up here and thinking, what do I put there? -4, because -4 times the x will make -4x. And then you do the -4 times the 1 makes -4. Draw the line. Don't forget, every time, opposite, opposite. Now when they add down, you get a 0 remainder, which means that these were factors, and I'll highlight them. This times this is equal to the red highlighted area. The blue highlights multiplied make the red one. That's the basics of long division of polynomials. Do you get that on number 19? It's more complicated looking. All right, let's start number 19 together. On the yellow packet now. Number 19. Okay, it gives me this big honking equation, and then it says x equals 0 and x equals 7 are x-intercepts. Hint, that means you know what the factors are. So everybody put this inside here. X to the 4th minus 4x to the 3rd minus 31x squared plus 70x. Now they say x equals 0 is an x-intercept. And x equals 7 is an x-intercept. So let's do the 7. It's easier because 0 is weird. But x equals 7, do you get that means I'm going to want to put a 7 here? No, it doesn't. What do I want to put there then? Yes? X minus 7 you're going to put there. But wait! There's a better way to do it. Because they said that 0 is a factor. So no, 0 is a root. That means x minus 0 is a factor, which I want you to think about that. Do you agree that x minus 0 is the same exact thing as just x? If x is a factor, that's saying, look, you can factor out an x. If x is a factor, you can factor out an x. Why would you want these to all be so complicated? Why don't you just factor out the x first? Does everybody do that? If you factor out an x, you're going to have x to the 3rd minus 4x squared minus 31x plus 70. Do you get when they said 0 was a root, then they were saying x minus 0 is a factor, which means x is a factor, and if x is a factor, that's just saying to factor this. Who would have thought in this class that factoring would be such a big deal? Once again, you had to factor. And when you factor that, you got this. Now, one more thing, this is important. That x we just factored out, we need to bring that down and put it in our final answer, because our final answer is going to look like this. It's going to have a whole bunch of factors, because when we're done factoring this thing right here, it's going to have all these factors, and x is one of them. There. Now I can handle questions. There was a hand up. Does it still have a question? Ask me now. Ruby.
Could you have done it without factoring the x out?
Yes, but it just would have been left. It would have been more complicated because the numbers would have all been bigger. And then at the end, you would have still factored the x out.
Okay.
Because we got to keep going until we factor it all the way. All right. So, how do we start this one? Well, I'm going to put an x here, and then you'll quickly realize x times x is x squared. That's not big enough. So, Henry, what should I put there instead? See, if I do this, I'm getting x squared here, and that's not working.
X squared.
Yes, you put an x squared there, and now multiply it out for me, Henry.
X to the third minus 7x squared.
Minus 7x squared. That's awesome. Just, you good? Now what? You were right so far. Now what do we do?
Flip the signs.
Flip the signs. Good. Now this and this, when I combine them, make 0. And then when I combine these two, I get 3x squared. And then I'm going to just keep on going. And remember that x minus 7 is one of my factors. They said so. So I'm putting it here. And then when you get your final answer at the top here, I'm going to highlight it in green. Up here, you know, that's the thing you're really working on, is the highlighted green area. Once you get that answer, you're going to factor it here and here. You're going to just keep factoring and factoring and factoring this thing. So there's some help on long division of polynomials. Your job tonight is pretty simple. We've got it down to, there's only 2 questions left in the packet we haven't talked about, okay? So we'll talk about those. In fact, now that I've just finished with 19, I guess it's 1 question left. And then you work on this packet tonight, and you hopefully finish them all tonight. And then tomorrow you can come back and go, which of the ones are scare you the most? If there's any there that you want to be like, oh, I need another practice on this. I can make practice problems. That's one of the advantages of me as a teacher. I have my disadvantages, but I can make you a problem like that. You pick any topic. I can be like, here's one like that. Okay, so you just have to ask, and I'll make you one. And then we'll practice it together. All right, so finish that up, and then later, finish that up. Right now, I'd like you to go to the back side of your packet, since you all have the packet out now and you were writing on it a second ago anyway. Okay, so x squared, this is on the back side. It's call it problem 20b. It's just like problem 20 in your packet, but it's brand new. X squared minus 9x minus 10 over x squared minus 100. And I want you to find me 5 things about this. Put a y equals in front. I want you to find the x-intercepts, which is where what? Y equals 0. And the y-intercepts, which is where what? X equals 0. And I want you to tell me if there's any vertical asymptotes. Hint, they come from the denominator. And horizontal asymptotes. Ask Bob. What are the other kinds? There's Bobs and there's Sobs, same on both. And bots like, what's that? Bot, bigger on top, but you're right. There is, bots don't exist. There aren't any horizontal asymptotes for that. Okay, so that's a quick reminder. I'll go through verticals and horizontals more in a second. But the last thing is a whole nother problem. Psh, try to find the hole. Holes are where you have factors on the top and the bottom, and then something cancels. I will show you again in a second, but first you try. Pausing for a second. So, here's some things that I wanted you to know, but I need to teach you now, because if you didn't know them, you got to get it now. X-intercept is where y equals 0. So I go put a 0 here, and how does that even help me? Well, if I factor the top, because if you can factor it, you should, then we have x minus 10 and x plus 1, and x minus 10 and x plus 10. And look, coincidence? Of course not. That gives me what it's called a hole at 10. 10 comma what? Does anybody know how to get the other part? Yes? Good. So 10 goes in here and here. And then you get 11 over 20. So that's where the hole is, at 10 comma 11 over 20. Now we were starting that by finding the x-intercepts. The x-intercepts are what makes y 0. So what I'm left with is a choice. Do you think negative 10 is what makes it equal 0? No. How about negative 10 down here? Well, that makes the bottom 0. Does that make it equal to 0? Well, it makes the bottom 0, but it doesn't make the whole function 0. Negative 10 is called the vertical asymptote. How many of you knew that? Excellent. Whatever makes the bottom 0, those are vertical asymptotes. Whatever makes the top 0, those are the x-intercepts. Please get the difference between those two. Whatever makes the top 0, those are the x-intercepts. Whatever makes the bottom 0, those are the vertical asymptotes. How about the y-intercepts? The y-intercepts is where x is 0. So you go put in a 0 here and here, and you would get 1 over 10. The y-intercept is where x is 0, so 0, comma, and when you put in the 0, you get 1/10. 0, comma, 1/10. The x-intercept was what made the top 0, which is x equals negative 1. That's what makes the top 0. Therefore, the whole function 0. And I said I would expound, or tell more at least, about the horizontal asymptotes. So here you go. Here's some notes on that. Notes that you may want to look over right before you take the test, so they're good ones. What if it's a bigger on the bottom? Do you remember the y equals for that? It's often 0, but that's not the answer.
The
Yes.
coefficient on the top.
Nope. Okay, so let's look back at this thing. Would you agree that this is got an x squared on the top and an x squared on the bottom? Zoe, you're missing something important here. So this one is a same on both. What if it was a bigger on the bottom? Let's say there was an x to the third right there. Do you guys remember the rule for Bob's? Yes?
Something with the outside.
Yes, if the outside, look outside the fraction, there's nothing there, so it's y equals 0. It is whatever's on the outside of the fraction. These are all fraction functions. It's y equals the outside. You can put usually 0. That's bigger on the bottom. What's next? Bigger on top. Do you guys remember I said no buts? What do you think that means about the asymptotes? There are no, these are all horizontal asymptotes. And bigger on bottom, bigger on top, same on both. Ooh, that's same on both. That's the one I'm missing. Same on both. That's like what we have. This one's same on both, because this is actually a 2 right there. So it's the same here and here. Do you get that there's a 1 here and there's a 1 here, and those are called the lead coefficients? So y equals a ratio of the lead coefficient. Ratio of the lead coefficient. So in this case, that's y equals 1. So our horizontal asymptote, it wasn't a bob. Ours was a sob. Y equals a ratio, 1 over 1 in this case. These again are called the lead coefficients. All right, that was a lot of info. Any other follow-up questions about 18, 19, or 20? So, or sorry, Jose.
Big 20, we talked about the rules with holes, like which one wins if you have like.
I don't want to confuse you with that. That we're not going to get into super deep weird ones where there's complicated hole versus asymptote. I'll just remind you, do you get that there was a hole in this case? Okay. And what if there was also an asymptote? That would have been if there was another x minus 10 down here, but both didn't cancel. Then you'd be deciding, geez, is 10 going to be a hole because it canceled here and here? Or is 10 going to be an asymptote because it's down there? And then if you're picking, which do you think wins between a hole or an asymptote? That's an asymptote. That's a hole. Yeah, the asymptote, because it's like more powerful. Okay. And there are even more complicated options, but let's not even go there. Okay. Now you have time for individual questions, and that's all I have for the video for today. Save and close.